Okay, let's get started. Good morning, everybody. And very welcome to Saltx Technology Interim Report 2 for the second quarter this year, this 25th of August. Carl-Johan Linér, CEO at the company here, and on my side here I have Harald Bauer, CFO.
Good morning.
As we usually do, and we have some PowerPoints presentations that we would like to show you, and then I think we have a great opportunity that you ask questions and on the chat, and we will try to answer them afterwards. You are free to put the questions already now if you have them, and that's very important. We think that we have some time to answer those questions. The pictures and the slides that we are going to show you today you might have seen them before if you are not a listener for the first time, but we think it's important that we all have the same picture and we know where we are and what we are heading at. We take slide number 2, and this is Saltx. As you know, for more than a year ago, we took the decision that we should focus on large-scale thermal energy storage application, and that was a consequence that we built this plant in Berlin, as you can see from the picture, which opened up in April 2019. We have patent families that cover the technology, which we think is very, very important. We are at the moment 16 senior staff people. That has changed since last time. We have actually recruited one person, Martin, who is a Master of Science and came from the car industry recently. So he's helping us since a few months back in time. After the rights issue we had in end of last year, we are today more than 18,000 shareholders. That's Saltx in a nutshell. We also know that the global storage market is big, it's huge, and it will actually double 6 times in the next 12 years period. And as you can see from the scale on the x-axis, we are in the beginning of this storage era market. There will be a number of various applications, of course, not only our technology, but the graph is actually showing stationary batteries only used in various applications, and also the pumped hydro storage is not included. So all the car industry electrical batteries are not included here. I mean, there's US, there's China, there's India, there's all over the place, and we know that when the fossil-free business is increasing, the need for storage, energy storage, will also increase. There will be different applications, different technologies, as I said, for different applications. And this graph actually shows us the discharge time rated power in combination with the energy capacity. The batteries, the gray area there is the lithium-ion batteries, and the yellow one is the thermal and energy storage application. So we are a complement, or lithium-ion battery is a complement to us. It depends on how you see it. When it comes to the number of operations, cyclings, and energy capacity. We think, and we know pretty sure, that this is the area that this is the area we should be at, and this is our focus. Pumped hydro is much bigger size, as you know, and that's a huge, of course, investments from that one. Some people talk about, well, not only some people, a lot of people talk about hydrogen here, and you can say that hydrogen is more or less in the same area as we are when it comes to the discharge time and the energy capacity. However, we think that the hydrogen is a bit more expensive solution at the moment, and it's also a risk factor that is quite high with hydrogen if something will happen during the storage. The need for peak shifting is still there more than ever before, I would like to say. And the thing is that we, in theory, we would like to charge when the prices is low, and then we want to utilize the storage to discharge when the prices is high, of course. But an example that actually came up this summer in June, I think it was, where actually we started the nuclear power station in south of Sweden, Ringhals 1 again. And we also started up an oil burner in Karlshamn that to be able to supply the electricity in south mid Sweden. And that's clearly a sign also of the lack of capacity to be able to take the electricity from the north of Sweden to the south. And that's a sort of another peak shifting also. It could be that we could have had a storage in place in the south mid Sweden that could have replaced the oil burner. Oil burner had a capacity of 600 megawatt, and I think they still are running. I'm not sure of that, but I think they're still running, and they don't know for how long. How does the Saltx solution work chemically? This is a well-known process that the calcium oxide works together with H2O, water, and which means that they put together with calcium hydroxide situation. The unique part for us is that we have patent also is that we nano coating the molecules, the particles, that so we avoiding agglomeration here. That is the core of the particles chemical industry, chemical solution. And this is then a reversible process also, and it's a circular process, you can say more rightly, and we are utilizing water, clean water to initiate charging and discharging. This is the way it works then. We put some energy in the process when we are charging, and this could be electricity power, or it could be waste heat also when we are charging it. And then there will be calcium oxide, the charged salt, and that's the storage itself. And once we are discharging, we put in 120 degrees Celsius steam to initiate the discharging process, and we come back to calcium hydroxide again, a circular process that could go around for a number of times. That is one full cycle, as we call it. But in reality also, we need to look next picture. Yeah, we need to put the storage into the real application, depending, and this could vary from installations to installation. This picture shows that if we are putting in 1 megawatt hour in renewable electricity, we will charge 0.62 megawatt capacity. What happened with the others? Well, the 0.38 will you can say will disappear if we don't take care of it. But in this case, it's very important that to get a high efficiency level, we have to take care about those 0.38 megawatt hours condense that the water is disappearing from the process, and that we could connect then to the district heating, where we could heat up the houses and the industry that are connected to the system. so that are utilized then, is not waste. And then when we are discharging, we put in 120 degrees steam, and then we get out 0.52 megawatt hours. So in principle, if you put in 1 megawatt hours to the left-hand side, when you do the charging, you get out 0.52 plus 0.42 megawatt hours, which is in this ideal case a very good efficiency rate. This could then, of course, varies from installation to installation, as I said. What makes Saltx different? This is probably also a picture that some of you have seen before, but we are in short terms, we are working with a temperature level of 550 to 800 degrees Celsius, steam, electricity, or waste heat. We have a very high energy density, 500 to 600 kilowatt hours per ton, compared to others, concrete or water. It's much higher density level than those material. Independently scalable, which means that you can charge the salt during a very long time if you want to do that with a low power, and you can then discharge it very, very quickly. So if you're getting closer to a seasonal storage, you might be that in situation that you would like to charge a battery for a long time, and then utilizing the battery during a short period of time. And this is a lot of in the past you did the calculation and dimensioning of the network on the maximum level. Now these days you don't need to do a dimensioning and calculation of the network on a maximum level. You can do it on a lower level, which means a lot of advantages when it comes to the cost, of course, combined then with the storage. Transportable, it's possible to transport this salt. You can actually charge the salt by, for instance, waste heat. There are a number of places in the industry that have waste heat in 550 degrees as we need. And then once you charge it, you transport it on a boat, on a ship, to another place, geographical place, that they could use the energy. So instead of peat or other fossil or other products from the forest, you could use salt here. And once you've done the discharging, you can transport it back again to the charging place in the industry. We have a thermochemical industry that varies between 1 hour and 6 months. They're all natural material. There's a lot of salt out there in the nature that we could use. It's a robust situation that we don't need to take care about. There's no risk for corrosion, all those things. And it's an economical system complexity, which is we think very economical. So that is in a nutshell Saltx. The different technologies, we have various energy density, and you see that we are 600, maybe more than 600, including the sensible part, which means that as long when the calcium oxide is new created, it's still hot, then we have this high energy density. But over time it will go down to 450, but that it will stay like that regardless of the storage time. So compared to molten salt, compared to concrete, to flow battery, to hot water, it's a much better situation with the number of kilowatt hours per ton that we could store. The main focus that we have and have had now is that we want to take the lessons learned and the experience from Berlin, where we actually had the moving bed situation, where we saw that the material non-alkali salt did not agglomerate. Scale it up. The Berlin was 0.5 megawatt size, and scale it up to much bigger storage applications. And that means, as a consequence of that, we had to change technology of the reactors. So we are today focusing on technology that's called fluidized bed, which is in some areas applications a well-known technology, but it's much better heat transfer coefficient, as you can see on the y-axis here. So we think that we can come up to 200 to 300 watt per square meter Kelvin, and later on we might be able to increase that even higher. This is a core technology and core competence in our company that we are building up now, to be able to understand the variables and to understand, to make the design in when regards to a number of parameters. It's a bit complicated, a little bit more complicated than the spiral joule, but we have been working with this, and we're still working with this, and I think we have a solution on our way. The fluidized bed could look like this. This is a picture from a drawing for our test rig in our own test laboratory here in Stockholm. And this is based on our technology and our technique here. And of course, we are talking to what we call OEMs that are producing and have the very long experience of this type of reactors. But we have, as you have seen from the press release also 2 days ago, finally we got an approval from the Swedish Energy Agency of 5 million Swedish crowns. And this application we actually put in September, October 2019. So the time that they have had to take a decision on this application was quite long. But that hasn't stopped us. We actually started end of last year. We actually started to made some tests and calculations on the fluidized bed to be able to save time. We did not sit and wait, of course, for the decision from the Energy Agency. And the application that we put in September, October last year was actually looking at replacing the hydration spiral joule heating screw in Berlin, Vattenfall Berlin. But now, since this pandemic that we have, we just got this approval now, 5 million. So we need to decide how we should handle this with regards to the pandemic. If we should build this hydration reactor somewhere else, closer to the Stockholm region, or not, depending that we would like to have it closer to us, of course. More people could be involved, and we will avoid traveling as we should not be doing. The design, you can say, is actually built on quite compact in size with regards to the length and width, but the height will be a little bit higher. Of course, this test rig is about 1 meter high, but in reality it will be a number of meters high. So what's important to remember, where are we on the arena? The ecosystem actually put us in the middle here, and to the left we have the partners, salt producers, which take care of the salt and also take care about the recipe for the nano coating. And Wacker, Nordkalk and Wacker is doing that, helping us with that, and we have a continuously dialogue with them. On the top we have the OEMs, which is really the key components, and here we have the reactors, of course. And to the right hand side we have what we call the EPC. That's the people or company that actually built the complete installations, install the storage plant, and in maybe some cases also take responsibility for the service and daily OPEX responsibility. And to the bottom we have the off-takers, the end customers that are actually placing the order hopefully to us, and this is the arena that we are at, and we are in the middle here, and depending on the time and the issue and the priority, we are moving in all those directions. So the partners that we have then, as you can see from this picture, is the producers, Wacker and Nordkalk. I already mentioned that. We have Germany, and a partner that called Steinmüller Engineering. Steinmüller we signed an agreement with them, and after a while it turned out to be the case that they were looking into another technology called molten salt that they had been doing for a while, and they told us that we want to finalize that research and investigation if that's the technology. So we stepped back for a number of months, and we still had a contact with them, of course, but we had to let them do that, of course. And then the pandemic came, and we don't know exactly where they are today, but the dialogues is still there, but on a very low level, not frequent at all, I have to say. So we need to take a decision pretty soon and talk to them whether they should be on our arena or not. We will see about that in the near future. Inerco really has done a good job. They are, of course, suffering because of the pandemic also very much. I think the most of those partners here. They actually put the budget into the daily business for this year, how to develop this business. That has been highly delayed now, and we are talking about maybe an installation 2021 here. Inerco did a lot of coal installations before, and of course they want to find some substitute for the coal industry applications, and that's the thing, as energy storage is very suited for them. We still believe in Inerco, of course, very much, but they are developing their own type of reactors also at the moment, and that will take time. China, Shanglian, also, of course, suffered because of the pandemic, but they are since a number of months back in business, so to say, and the economy has opened up. They are building a 50 kV installation based on a spiral joule heating screw charging and a fluidized bed discharging. And they have a number of partners to them to supply the expertise, knowledge about the reactors. We have delivered the test material to them, and actually has arrived, and they have made some tests of the salt. We don't know the result of the test yet, but Shanglian are in the lead, as you can understand from those partners, and we still have the target that we should that is 50 kV installation at Shanglian premises should be ready this year. I think they have opportunities and they can do that, of course. But it's very important in all those processes here. It's very important that we protect our patent and our patent not only for the nanocoated salt but also for the development as I described earlier about the reactors, fluidized bed. So effects of pandemic. We have. I've told you about the partners update, internal operations in our office here in Stockholm. We have been working very much from home. We have done the meetings on the video conferences, and I think it's worked out pretty well. We have an office that is quite a lot of space due to the reduction of people that we have done also. So we have not been suffered as much as our partners when it comes to the pandemic effects. We have been able to continue our development in a pretty good way. Berlin. A few words about the Berlin case also. We are in connections with Vattenfall, of course. They know about this cost 5 million kronor that we got from the Swedish agency, and we think that due to that's the reason why Berlin is under the COVID-19. We think that Berlin is not that suitable to do this fluidized bed installation on the hydration reactor. We are looking into this, what we should do here, the scope and the geographical area, but we would like to have this fluidized bed closer to the Stockholm office with regards to the COVID-19. By that, Harald, it's time for you to say a few words about the financial comments about the situation.
Thank you, Carl-Johan. Just from the financials, you can see the effects of the downsizing. We've reduced the number of people working in the company during last year, and therefore our cash outflow is lower in this year than compared to last year. However, though, it's important for us to work effectively with the people we are, and that Carl-Johan then has described what we focus on, and the primary strategy is then to focus on energy storage solution. And then, of course, to make use of the available funds as efficiently as possible to make us last as long as possible going forward. And then with a contribution from the State Energy Agency of 5 million is a contributor to that, and a part of it, a smaller part of it, will be paid out this fall in Q4, and then in line with our spendings within the project going forward. And the project lasts for about 2 years. And we have other applications with energy, the Energy Agency, and we hope to have positive results from those applications as well, and thereby continue to have public funding from part of our operation in combination with other sources of funding. Okay, thank you, Carl-Johan.
Thank you, Harald, very much. We then have time for questions and answers. Do we have any questions coming up? During the time when you are writing the questions, I can maybe say a few words that we didn't say anything about graphene. Graphene is an Alström-Munksjö, as you maybe have heard about. Alström-Munksjö have given the highest priority to decided to support the pandemic need of filter in front of your mouth. I don't know what the word is that for in English. to be able to produce that material. So they have actually changed the production in their factories. It's still valid, the graphene. They're still talking to us, but we are not making any development in this research and development in this area. The graphene application is suitable for smaller applications, and since we are running on a bigger applications, we say that we are not going to develop anything here. We are focusing on a big scale, but they are still maybe still interesting to make some sort of installation into one of their own factories, a small installation, and we will of course supply the nanocoated salt, no doubt about that, but they have to make the job in that case.
Then seems that there are fewer people on this line, on this conference than the
What
Swedish
happened
one.
in Berlin then, Harald? What happened there?
What happens there? At the moment, the pilot is still there. It is not in operation. We concluded some important results and communicated those in September of last year. And we realized that the reactors chosen in Berlin are not scalable. So we continue to cooperate with Vattenfall to find other solutions. And we presented those today to be based on fluidized bed technologies instead. And it may well be that we find a solution to have that in operations in Berlin, though we are considering to set up such test pilots closer to home. Then it's more efficient for us, as well as then more appropriate in the times of the pandemic.
Mm-hmm. Good.
Well, time's up.
Okay. I suggest if you don't have any questions more, it doesn't look like that. We close the meeting, and we thank you very much for your listening and your support and good thinking about Saltx technology. We are on the right track to the energy storage big scale applications, that's for sure. Thank you again.